I don't even remember how many times I have done this, but alrighty, welcome back to the drive-thru, everybody, for like the quadruple remix. And this is a special Kung Fu edition of the drive-thru. Go ahead and stop by the deli and grab yourself a peanut butter and jelly sandwich with a bag of Pringles. Uh, so I'm going to go ahead and show you guys some awesome programs that you can use to help you with some of the stuff we learned in Chapter 9. First, we learned about geometric sequences, which is when we multiply by a common difference. And then we have arithmetic when we added by a common difference. And then we have arithmetic series. And then we have infinite geometric series. And then we have finite geometric series. So I'm going to show you guys how to use a program for all of those that I have. If you are face-to-face, you can come and see Mr. Yuland or myself. And if you're virtual, I will have the program link files on Schoology, so you can download those if you want to. So we'll go ahead and start with our first program. We'll go ahead and start with arithmetic. So when it's asking for the first term on my program, it wants to know what the first term of your sequence is. So in this case, we've got 4 as our first term. Our common difference. So we're adding by 4 every time. So that is what it's asking for there. And then our term number. This can be any term number you want to find. So if you want to find, let's say, the 10th. No, let's make it the 11th term because it's Veterans Day. Also my birthday. We'll find the 11th term. And now when it says number to sum, it's asking how many numbers are in that sequence, so it could add them all together for you and give you the sum of that sequence. So let's say there are 11 numbers as well. So there we go. The 11th term of this arithmetic sequence is 44. And then our sum is 264. Pretty awesome stuff there. So now we're going to go ahead and do geometric, which is geometric, so our first term again, you look at what the first term is in your sequence. So we got 3, and then our ratio, or the common difference. So it looks like we're multiplying by 3 every time, because 3 times 3 is 9, 9 times 3 is 27, and 27 times 3 is 81. So our ratio is 3. And then the term number again is what we want to find. So let's say we want to find the 5th term. We want to find the next term in this sequence. And then let's say there are 10 numbers in this sequence. So there we go. So the 10th term is 243. And our sum is 88,572. And to show you that my program does work, we'll do 81 times 3. Look at that, 243. There it is. That works. It matches with our answer from the program. So there's a little proof for you that is indeed working correctly. So next we're going to work on arithmetic series. So for this program, you're going to need to find the number of terms. So if you have a question like this, I already added to fill it in. But you need to know when it's asking for n, it wants to know how many terms there are. So in this one, we have 1, 2, 3, 4, 5, 6, 7, 8 terms. So we'll type in 8. And then when it's asking for f, that is just my way of how I programmed it to asking what the first term value is. So that is 5. And then L stands for last term value. So we got 26. And this should indeed calculate. Yep, there it is. 124. So, and then to show you that this does indeed work, you could also check your answer by adding 5 plus 8 plus 11 plus 14 plus 17 plus 20 plus 23 plus 26. See, our answers match. So this is a great way to just save some time on your free practice and your tests so that you can spend more times on questions that are more difficult. So let's go ahead and move down. So now we're going to work with infinite geometric series. So I have another program for that, and that is going to be this program here, IGOSum. So go ahead and enter that in. So when it's asking for A in this question, we're talking what is the first term value? So let's see what our first term value is. So we're talking 8. I need to bring that up. 8. And then our R, which is our rate of change. So we're talking 0.5 because we're getting smaller. So we're talking, oh goodness gracious, 0.5. And then there we go. We got 16. So the sum of this infinite geometric series is 16. And remember that this one only works for less than 1, as this does converge, and I do not have a program for when they are greater than 1. So this is for less than 1, when your rate of change is less than 1. So our next one is going to be ethnic geometric series. So this one works pretty similarly. So we're going to go ahead and pick FGeoSum. So A, again, is going to be our first term value. So we got 40. And then our rate of change, which is also ironically 0.5. And then our N is our number of terms. So they indicated that we have 10 terms, or yep. So therefore, there's our answer. So it's, oh goodness gracious. So there, it's 79.921875. So you just round it to whatever they wanted, or put that in if that was your exact answer. Again, if you need help with adding these programs to your calculator, come see me, Mr. Yoland, or Mr. Pletz, and they'd be happy to help you put these to your graphing calculator. Boom!